Well, hello Internet, and welcome to part 6 of my C# video tutorial. In this part of the tutorial, we're going to talk about public, private, protected, constants, read-only fields, constructors, setters, getters, properties, and static. And like always, all the code as well as a transcript of this video is available in the description underneath the video. And I have a lot to do, so let's get into it. Alright, so here we are once again ready to program. Now what I went and did was I went and created an animal class, and I showed you how to make classes previously. You just go up into project and then you come down and you look for add class and you type in the name of the class you want to create. Now inside of this class, what I want to do is I want to define a couple different fields, and I want to protect the data so that it is hard for the user to go in and just give any value it could possibly want to any of the fields I have in this class. And one way to do that is to label a field as private. So I'm going to have a private string and name, and then I'm going to have another one, and it's going to be a string also. And it's going to represent a sound that my animal can make. Now you already saw public. Basically, by labeling a field as public, that means that the user would be able to go in there and willy-nilly change anything. We also have another version which is protected. Now what protected means is that the value can be accessed by methods inside of the class, but also subclasses. Private, on the other hand, can only be the value for a private field can only be changed by a method inside of the field, and the subclasses also won't be able to change it. And I'm going to show you a whole bunch of examples here to make all this much more clear. Another thing I wanted to cover is that you can also define constants inside of your classes. So let's say I have an animal shelter, and I want to make this a constant, and I could give it a name such as Derek's Home for Animals. And that value, once defined, cannot be changed anywhere. So that is a constant, and that's why it's called a constant. Another thing that C# introduces is what are called read-only fields, and they are going to be set at runtime inside of your constructors. They can't be defined anywhere else. And once they are defined, they can't be changed. So it provides a way for you to create a constant that can be changed at runtime. And how you define one is you define it as read-only. And I'm just going to make an integer, and this is going to be like an ID number that's going to represent my animal shelter for all of my different animals. Okay? Of course, within your class, you're going to be able to define a capability for your animals. And so let's say that I want to say that my animals are all going to be able to make a sound. And what this is going to do is just output on our screen some information about our animals. So we'll say something like the animal's name says, and then the sound that that animal makes. We are then going to be able to pull in that information by going name, and then once again we're going to be able to pull in the sound for our animal. Now I want to get into a little bit more complex way of defining constructors. So you saw previously where we were able to define our constructors like this. Of course, we are going to use the same name for the constructor, which is going to initialize or define all the different fields for our animals upon creation. But what if you would like to take the information that was passed inside of here and then pass defaults up the chain to additional constructors? You would be able to do that. All you need to do is go colon and this, and then let's say that this constructor is called whenever no information, no parameters are passed to this constructor, and we want to define some defaults. So I'm going to say that I want to define no name and no sound for the different fields whenever this constructor is called. So there we are, and there we are. And then the weird thing you do here at the end of this is you put your little curly brackets at the end there. All right, so we're going to come in and we're going to define some additional constructors as well. So we're going to define also a constructor in which it's just going to receive a name. So we're going to type in string and name, and then we want to pass this up to an additional constructor. So in this situation, we're going to say this, and then we're going to pass in whatever name they pass to us, and then we're also going to pass in a default no sound, and then we are going to put our curly brackets at the end there once again. And it's just giving me an error saying we do not have a constructor that receives 2 arguments. Well, I'm going to change that right now and define public animal, and this is going to receive a name as well as a sound. So let's type in both of those. And then this one is going to properly define everything. And so what we're going to do is I'm going to show you how to use getters and setters and all those different things. Let's just keep this fine the way that it is right now. And let's come in here and define a setter and how those work. Now basically, setters or mutators are going to protect the fields from receiving bad data. And how we define them is we can go public and void, and I can call this set name. I'm going to show you a couple different ways because there's a couple different ways to define setters. And we use things called properties. You're going to see it all. Alright, so what we're going to do inside of this is we want to check if any character in the string for our name is a number, and if so, what we want to do is we want to say that that's not a valid name. So how can we do that? Well, we can come in and we could say if and not, and then we'll put name, and then what any is going to do is it is going to check every single character, and it is going to see if any of those is a digit. If this comes back as true, this is going to change this into a false statement, meaning that there are no numbers. And in that situation, what we're going to do is we're going to say this name is equal to the name that they passed in. So we're going to say that that's valid, that they were, they passed in a valid name. All right, so that's one way to check data, and that's one reason why we have setters and getters. And otherwise, we can come in and say else, and we could say something like this: name is equal to no name, and then we can output like an error message or something on the screen, and that error message says something like name can't contain numbers. And there's all kinds of cool little functions like any inside of C#, and we will cover them as the tutorials continue. We're also going to be able to define what are called getters, and a getter or an accessor is going to be able to provide output aside from the value that is stored if that's something that you need to do, which very often it is. Let's say that we store a weight and we want to output what type of weight it is, like pounds or kilograms or something like that. Well, we could store the raw weight inside of it, but whenever we call for output or the getter in this situation, what it's going to do instead is it's going to also slap on that pounds or kilograms or something like that. But in this situation, we're just going to return a value. And to do so, we can just say return name exactly like that, except we're going to spell name right. And there we are. So that's an example of a getter. Now, in C#, I like to cover every way of basically doing things. But normally in C#, what you're going to want to do is define your getters and setters through what are called properties. And how you do that is you go public, and I'm going to do this with sound. So the name thing is going to be done in one way, and then we are going to define sound in the proper way using properties. Then we're going to define exactly what our getter is going to do. In this situation, it is just going to return sound. Okay, so that's cool. And then we can also define our setter in exactly the same way, except in this situation, what we want to do is, let's say we want to verify that the length of the sound isn't too long. So we could say something like value length, and then we can check that it's not greater than 10. And in this situation, if it is greater than 10, we want to set the value for sound equal to no sound. We want to set it back to its default. And then let's say that we also want to come in here and we want to output an error message on the screen. And we're going to say something like sound is too long. And there that is. And otherwise, if the sound isn't more than 10 characters, what we're going to do is just say sound is equal to value. And value is like the default variable that is going to store what is passed into the setter function that is going to be defined inside of here whenever you're using properties. All right, so there's an example of a property. Another thing that's really cool is you are actually going to be able to have C# automatically generate the getters and setters for you. And you're also going to be able to define defaults. So let's come out of here, make sure that we are outside of our property that we defined right there. And how you do that is, let's make this public once again, and string, and let's say that we want to define an owner for our animal. We can do so, and then we can come in and say something like get and set, and then we can also define that there is no owner. That is going to be the default value that is going to be stored in the owner field if nothing is provided. All right, so that's how we automatically generate those. And of course, you're also going to be able to define static properties inside of here. So we can just go static, and let's say we want to store num of animals, and let's give that a default value of 0 to start off. And then let's define the getters and setters for this guy, and we'll go public static, and this is an integer, and we'll go num of animals. And for this static property, we're going to say get, and that's just going to return whatever is stored in num of animals. So really simple. And then we're also going to define set, which is going to be num of animals, and then we will increment the value for that guy. All right, so there we go. We have just defined a whole bunch of different things. And let's change this to num of animals, and let's change this to animals. All right, have to verify that all those are exactly the same, and also change this to int. Oops, a couple slip ups. All right, so all of that is cool now, and we have all those set up, and now we can go up and use these inside of our main constructor file. And that guy is right up here. There it is. All right, so if we want to come in here now and we want to set the name, we will use our first way of using setters, and we're going to call set name and pass name inside of it. And then we will use our default name for working with sound, which is going to be this guy right there. So in this situation, it's going to call set name, of course, and it's going to go in there and verify that there are no numbers inside of the name, and so forth and so on. And you can see here is get name, and then here you can see exactly how we're going to use properties instead with sound to make sound work. As you can see, there's a capital S there for sound. If we want to increment the number of animals, we can come in and go num of animals and pass in 1, meaning that there's one additional animal, and that 1's going to get passed into this guy down here, num of animals, this guy right here, and it's going to increment the value of num of animals. And then we'll come back up inside of here once again. And let's say we want to define a read-only value. Like I said before, this value is going to be the same for every single animal that is created. So let's say that I want to have an ID number that is going to be associated with my animal shelter. I can come in and go new random and generate a random value, and then go ID number is equal to random and next. And let's say I want to generate a number between 1 and let's use one of the big giant huge integer numbers so that we can pretty much guarantee that it's going to be a pretty big number. Whoops, change that to a 4. Okay. And now that we have defined all these different guys, what we're going to do is jump over into the program.cs file and use them. All right, so here we are inside of main, and what we're going to do is we're going to create a new animal, and I'm going to call it cat is equal to new animal. Now, if we want to call the setter for the set name, we go cat, and we're going to call set name, and we'll give our animal the name of Whiskers. We can then also set a property for cat, and how you do that is go cat and sound is equal to meow. I think you can see why using a property is better than using these functions. You can just assign the value, okay? Looks nice and neat, look good stuff. Now we can come in and we can go and output some information here. Let's go and output the name and the sound for our cat. So we can say the cat is named and pull the name out of there, and says and we can pull out the sound for that guy also. And to go and get those, we can go cat and get name, and that's the function we call. And then once again, we're going to go cat, and to get the sound using the property, you're going to see that this is better because it's nice and clean. And let's run it and see what happens. And there it is. The cat is named Meow and says meow. What are we doing here? Oh, I see. I forgot to put that in there. Let's go and do 0. The cat is named Meow and says meow. All right. Now it says the cat is named Whiskers and says meow. All right. So good stuff. So now what we're going to do is we're going to come in here and work with some of those other things that we created. So let's go and test our auto-generated getters and setters. So to work with the owner, we're just going to go cat owner is equal to, and we'll just throw Derek inside of there. And now let's go and output that information. So we can say console and right line, and then inside of here, we'll go and get the name. So we'll say like that, and then we'll get the owner for our Whiskers animal, and then we'll go cat and get name, and then we will also come in and go cat and get the owner out of there. And while we go and get our read-only properties and all our other stuff. So to get our read-only property, let's just copy this one. We don't have to type all that out again. We'll just go paste that inside of there, and we will say something like shelter ID is, and then we can come down and leave this as get name. And then if we want to get the read-only property, we can just go ID num. And remember that ID num was a public value that's available to us. We don't have to call a function for it. And let's also come in and test our static property. So in this situation, we can say num of animals. Let's just put a number sign inside of there of animals. And then let's output the number of animal objects that have been created. And to do so, you're going to have to call the class, because remember, static fields belong to the class and not to the instances or the objects that are created. And to get that, you're going to call num of animals. And we can save that. And we can reload it, and you're going to see the cat is named Whiskers and says meow. Whiskers owner is Derek. You can see we auto-generated the shelter ID, which is the same for every single object you ever create, and the number of animals is 1. We can also come in here, and we can go and create another animal just to verify that this is going to increment. So we can say animal and fox is equal to new animal, and we can call our fox Oscar, and we can go for our fox and generate that guy and run it. And you're going to see now that the number of animals is equal to 2. All right, so that is good stuff there. Just wanted to cover this because C# is slightly different than a lot of other object-oriented languages in regards to how many different ways you can work with setters and getters, and how encapsulation in general works. And encapsulation, once again, is just a way to protect our data, like we did here with name, saying that the name cannot contain a number. And that is a whole bunch of information, and in the next part of the tutorial, I am going to cover polymorphism and all the other little whiz-bangs in regards to how to use object-oriented programming inside of C#. And like always, please leave your questions and comments below. Otherwise, till next time.